Alright, hey folks, here we are on day number 7. We're going to talk a little bit more about radius and interval of convergence, as well as derivatives and integration of power series. So let's start with this little warm-up problem I've got here, which asks for the first 3 non-zero terms and the general term for the power series representation of that. So here's your general term. Right, where you have n in your general term, whereas the other terms, non-zero terms, don't have n in them. So let's first put this function f of x into the form we're looking for. Recall from yesterday, if f of x equals 1 over 1 minus x, that's the equivalent of the power series from 0 to infinity of x to the nth power, right? So if we can get in that form, we can manipulate it. Alright, so what I would do here is I would take out a 1/3 and I'd have this as 1 minus x, oops, oh, I'm running out of space here. Let's try this again. 1/3 times 1 over, notice this is a plus, that'd be 1 minus a negative x over 3. That's just the x squared. Okay, so let's turn that into a power series. N equals 0 to infinity. We would have a 1/3. Let me pull that 1/3 out here. And just for the moment, let's write this as negative x squared over 3 to the nth power. Now let's simplify that. That'd be n equals 0 to infinity of 1/3. I'm going to have an alternator here, so negative 1 to the nth power. And that'll be, what? X to the 2n over 3 to the n. Alright, cool. So now if I take now and I bring this 1/3 out here inside, that's going to change that 3 to the power of n. So we have our alternator, we have x to the 2n over 3 to the n plus 1. Let's see if we have, maybe we can expand this series and see what we'd have here. Okay, so what you'll notice here is my general term here is going to be this, right? But I don't see that in the form up here in one of these 4 options. So clearly these two here are out. I'm going to go with A as my answer. Let's expand our first 3 terms. So let's go with n equals 0. Well, if n equals 0, I would have 1/3. If n equals 1, we would have a negative x squared over 9. If n equals 2, we would have a positive x to the 4th over 27. Let's see, those are my first 3 terms. Looks like A is the correct answer. Alright, let's move on. We're going to work with derivatives and integrals of power series. Okay, so I want you to find the integral and derivative for f of x equals 1 over x. The reason we want to do that is we want to recognize a couple different situations where we're going to be able to utilize derivatives and integrals in order to manipulate and then take the derivative or integral of the power series that comes from that. Okay, so I'm going to pause the video, I'll come back with the derivative and integral. Alright, so here you have it. In the first part I use substitution, set u equal to 1 minus x, so du equals negative dx. So negative du equals dx. Therefore I'd have negative, or negative 1 times the integral of 1 over u. That should be a du. My bad. Let's change that to du. So when I integrate negative 1 over u du, I get negative natural log of u, which is 1 minus x, plus c. So if I have the natural log of 1 minus x, or some form of it, I know I can get back to a power series using derivatives. Okay, now if I take the derivative of f of x, I wrote it in power rule form, I would get the following using the chain rule. I would get 1 over the quantity 1 minus x squared. Alright, so let's see how we can use that on the next page. Okay, just before we get to the use of what we did on the previous page, I'd like to look at something very important. This we already know here up at the top. If f of x equals this power series, then f prime of x, we're just going to use the power rule because a series comes out to be in polynomial form. Then we can use the power rule everywhere, which is great. That's why this is so useful. So the derivative would be bring the exponent down in front, reduce the power by 1. Same thing with the integral. We would add 1 to the exponent and then divide by that same thing. Now, if we wanted to take the integral, a definite integral of some series, what would need to happen is this interval would has to be in the interval of convergence. If it's not, then it doesn't exist. Okay, that's the important thing here. The other thing that I want to bring to light here is when I take the integral in terms of x, all I'm doing is integrating any x term. So the -3 alternator here and over the square root of n plus 1, I'm not changing that at all. It's just a constant. That's all that is. So I'm just working with x to the n. So if I integrate, I get x to the n plus 1 over n plus 1, and then I simplify from there. Okay, so let's get that and use that, or that idea, as well as what we did on the previous page. Okay, so here I have, I'm going to find the power series for f of x equals 1, a natural log of 1 minus x. Okay, so 1 over 1 minus x equals the power series from n equals 0 to infinity of x to the n. Therefore, their integrals should then be the same. Now, what we did on the previous page is we determined that the integral of this was negative natural log of 1 minus x plus c. Over here, if I integrated this, I would get this sum from n equals 0 to infinity of x to the n plus 1 over n plus 1. Now this plus c is hanging around here, but I want to get rid of it, and I'm going to show you how. If x equaled 0, okay, basically what would be happening over here is as I'd be expanding this, let me show you what it would look like. The first term would be x, the second term would be x to the second over 2, then it'd be x to the third over 3, then it'd be x to the fourth over 4, and that would go on forever. If x equaled 0, what is the natural log of 1? Well, then the natural log of 1, if x equaled 0, is 0. So I'd have 0 plus c equals a bunch of zeros, right? I have 0, 0, 0, 0, etc. Therefore, you can see that c would equal 0. Alright, so now let me go back. We'll scratch c out of this scenario here. And we'll make this an x. And we'll work from here. So what I'm trying to do is I'm trying to evaluate what the natural log of 2 is. Okay, so for this situation, if I want to manipulate this to be the natural log of 2, and I want to approximate that, I got to know what to plug in for x. Now this is sneaky because someone might think -1. 1 minus -1 is 2. However, this negative over here is going to take and bring the exponent up here to this. Okay, so we can move that up using rules of logs. So if I had the natural log of 1 minus x to the -1 power, that's the same as the natural log of 1 over 1 minus x. Now, if I had 1 over 1 minus x and I wanted it to equal 2, the only way I could get that is if the denominator is 1/2. So 1 minus x has to equal 1/2, which means x has to equal 1/2. Okay, so in order to get the natural log of 2, we got to plug in 1/2 for x. So let's clean this up here. So if I plug in a 1/2 for x, I should get the natural log of 2. So let's do this. Okay, and let's plug in a 1/2 for each of these. So I get a 1/2 plus a 1/2 squared over 2 plus a 1/2 cubed over 3 plus a 1/2 to the 4th over 4, and on down the line. Okay, what am I trying to approximate by doing this? Well, this is 1 over 1 minus 1/2, right? Or this right here is x. Okay, so my calculator, if I type this in, gives me 0.682, right? If I type in these 4 terms. Now this is going to be an approximation. If I actually type into my calculator natural log of 2, it pops out 0.693, so it's actually pretty close. So the sum of the first 4 terms from n equals 0 to 4 of my series, right, which I have right here, x to the n plus 1 over n plus 1, yields me this number. If I were to increase this number to a 5 or a 6 or a 7 or an 8 or so forth, it would get closer and closer and closer to the actual. Alright, so here we go. Let's try to apply this to the situation here. Alright, so this would be the same as 1 over 1 minus a negative x squared dx. Okay, and I can do a direct translation of that into a power series. Once it's in that simple form like we have up here, that would be negative x squared to the n power. Alright, looks like we'll have an alternator on this one. Therefore, this would be the integral of the summation from n equals 0 to infinity of an alternator times x to the 2n. When I integrate that, that would be the alternator is not going to change when you integrate, guys, because it's a constant out in front, so it's not going to change. So we'll keep that there, and then we go ahead and we adapt this. Again, when we integrate, remember we add 1 and then we divide by that power. So this power series right here would represent arctangent of x. Now the important thing that you understand is that this is only applicable, right? Only applicable on the interval of convergence, whatever that interval of convergence is for that power series. Only for values of x within that interval. Alright, let's get started on a couple homework problems. Okay, so basically what I want to do is I want to look at each of these 4 problems, and I'm gonna highlight and do B and then D, I believe. And I want to somehow find a way to make these functions look like our original power series function, right? 1 over 1 minus x, which of course that should be burned into your mind at this point. So when I look at this function in part B, what I see is if I take the derivative, I'm going to get something that looks like f of x equals 1 over 1 minus x. So I'm going to take the derivative. Okay, so the derivative of f of x is going to be equal to 1 over 1 minus 3x times the derivative of the inside, which is negative 3. Therefore, f prime of x will equal negative 3 over 1 minus 3x. Alright, so I can go ahead and I can create a power series from this. Alright, that power series representation, so recall f prime of x is going to equal, I would pull out a negative 3. Alright, so let's get this in the form we want first. That would be negative 3 times 1 over 1 minus 3x, which is perfect. That's exactly what we want. So we got the negative 3, and we got a 3x to the nth power. So f prime of x is equal to the summation from n equals 0 to infinity and I'm going to go ahead and bring this negative sign out in front. That's not going to create an alternator because it's not inside here, right? So I'm going to have 3, see if you can stick with me here, 3 to the n plus 1 power times x to the n. Okay, so the 3 out here times the 3 to the n on the inside will give me 3 to the n plus 1. Alright, so that's for f of x, or f prime of x. I want it for f of x, so I'm going to integrate both sides, dx. So integrating both sides will give me f of x on the left, and on the right, I would get, again, the sum from n equals 0 to infinity of 3 to the n plus 1 times x to the n plus 1 over n plus 1. So right there, I mean, you can make that a little bit more compact if you wanted to write 3x to the n plus 1 over n plus 1. That would be just fine as well. But that would represent natural log of 1 minus 3x in power series form. Okay, let's look at D now. I noticed with D that if I took the integral of both sides, I'm going to get something nice here. So the integral of f of x dx is going to be equal to the integral of 1 over 1 minus 2x quantity squared dx. Now I'm going to go ahead and probably do this using u substitution, where du will equal negative 2 dx. Therefore, negative 1/2 du equals dx. So I'm going to do a little u sub here. So this would be negative 1/2 times the integral of 1 over u squared. I'm going to put that in this form. And I'm going to do some integration on that. So that would be negative 1/2 times, I'm going to add 1 and multiply or divide by that negative 1, right? So I'm going to add 1, u to the negative 1 over negative 1. Alright, so let's clean that up a tiny bit here. Negative 1/2 times negative 1 over u. Okay, so these would cancel, and I get 1 over 2u. What is u? u was 1 minus 2x. Okay, so what that is that's the integral of f of x dx. Okay, let's put this in power series form. The integral of f of x dx is equal to the summation from n equals 0 to infinity of 1/2 times 2x to the n power. Therefore, if I clean that up, I'm going to get the summation from n equals 0 to infinity. Check it out now. This is going to be 2 to the n minus 1 times x to the n. How'd you get n minus 1? Well, 2 to the n over 2 is going to be 2 to the n minus 1. Alright, so I've got this power series for f of x. Now what I want to, or for the integral of f of x. So now what I want to do is I want to take the derivative of both sides. So I take the derivative of both sides. That makes the left side f of x. That makes the right side the summation from n equals 0 to infinity of 2 to the n minus 1 times x to the n minus 1 times n. Alright, so one more time, let's clean this up. I don't like the way that looks. F of x can be represented by a power series written as n times 2 to the n minus 1 times x to the n minus 1. Here it is. What we can do, like I said, is we can manipulate anything that we're familiar with, right? If we know the derivative of something looks like that, we can use it to find a power series. If we know the integral of something looks like that. We can also do the same and then use the opposite operation to then get us back to where we need to be. All right, so that is lesson 7. Hope it went well for you, and we'll see you next time.